this lesson we're going to talk about calculating concentrations. Now the big idea here is that ion concentration can be calculated like any stoichiometric calculation as long as we have a balanced equation. Now what is ion concentration? Well, just like stoichiometry, when reactants turn into products, we can think of solubility as that solids turning into ions. So it's solids turning into ions. Like for example, when you have NaCl, sodium chloride, when it dissociates into water, it turns into sodium ions and chlorine ions. Now what you notice is that it's a 1 to 1 to 1 ratio. Now another example we have, such as for example if you talk about calcium chloride, which is CaCl2, when this dissociates, it'll be calcium plus 2 plus chlorine minus. But if you look at this, you have 2 chlorine ions, or 2 chlorines in calcium chloride, thus you must make it balanced. There must be a 2 here. So we gotta make sure that we know that these are how it's still balanced. So, still must be balanced in a dissociation equation. So, if the reaction / dissociation is in the same volume, then what that's going to lead to is that their moles will relate. And if their moles relate and they're in the same volume, which equals their concentration relates. So an example of that would be, let's look at the calcium chloride example. In the calcium chloride example, if you have 1 molarity of calcium chloride, then that means you have 1 molarity of calcium ions, but 2 molarities of chlorine ion, because there's twice as many moles of chlorine present. So let's practice that with our calculations. So example 1. If the concentration of calcium nitrate is 1 molarity, what's the concentration of its ions? So first of all, you gotta write a dissociation equation. Calcium nitrate, when it breaks apart into calcium ions and nitrate ions. But there's gonna be 2 sets of nitrate ions. So that means if you have 1 molarity of calcium nitrate, you have 1 molarity of calcium, but 2 molarities of nitrate ions. Okay, let's take a look at this next one. If 300 milliliters of 2 molarity NaOH is mixed with 600 milliliters of 5 molarity MgI2, what is the concentration of each reactant in the resulting solution? What is the concentration of each ion in the resulting solution? Okay, so this one you have a dilution question. So this is dilution. And you remember, dilution is C1V1 is equal to C2V2. And we're going to treat each of these as individual dilutions. What we also know is that V2 is equal to 900 milliliters. Alright, so what we have here. So this question here, our first one, let's look at NaOH. In NaOH, we have a C1 of 2 molarities. We have a volume of 300 milliliters. Is equal to C2 times 900 milliliters. Divide both sides by 900. And what you're going to get is C2 is equal to, if we plug this in our calculator, 2 times 300 divided by 900 is equal to 0.66 repeating. 0.667 molarity. Okay, for MgI2, same thing here, but for this one, it is 5 molarity times 600 milliliters is equal to C2 times 900 milliliters. Divide both sides by 900. And what you're going to get this time for C2 is, you're going to get 5 times 600 divided by 900 is equal to 3.33 molarity. Okay, so what you have here is this is your molarity of NaOH, and this is your molarity of MgI2. But what is the concentration of the ions? Well, first of all, you got to write down its dissociation equation. So for NaOH, we know its resulting concentration is 0.667 molarity. Well, when NaOH dissociates, it dissociates into Na plus OH minus. What will the concentration of each of these be? Well, they're both 1-to-1 ratio. It'll be 0.667 molarity. The OH will also be 0.667 molarity. Okay, for MgI2 though, this is where it differs. Because MgI2, you're going to dissociate into magnesium plus 2 moles of iodine ions. And if the magnesium is 3.33 molarity, what will the iodine be? The iodine will be twice as many, which is 6.67 molarity. Because it'll be double that. Because it has 2 for every 1 mole of magnesium iodine. Because when magnesium iodide dissociates, it will always break apart into 2 iodine ions. Let's try the last example. In the last example here, again, we have a dilution equation here. Okay. So if you look at this, you would see that your first one is you have a V2 equals 75 milliliters. That's the first thing. So let's do aluminum bromide first. Aluminum bromide will first of all be 0.25 molarity times 50 is equal to C2 times 75. Divide both sides by 75. You're going to get a C2 for aluminum bromide of 0.25 times 50 divided by 75, 0.1667. For calcium bromide, you're going to get a concentration of 0.3 molarity times 25 is equal to C2 times 75. So divide both sides by 75. These cancel, just like these ones cancel. You're going to get a C2 this time of, so 0.3 times 25 divided by 75. You're going to get 0.1. Okay, so that's the concentration of calcium bromide. Now let's talk about the ions. So let's look at our dissociation equation. Okay, so if you look at aluminum bromide, when aluminum bromide dissociates, it'll form into aluminum plus 3 plus bromine. But there's going to be 3 of these ions. Okay, what is the concentration resulting? Well, it's 0.167. 0.167 molarity. That means aluminum will also be 0.167 molarity. But what would the bromine be? Well, because there's 3 ions of bromine, that means that 0.167, or 66 repeating, will get to multiply by 3. And you're going to get 0.500 molarity of bromine here. If you look at, for example, calcium bromide, will dissociate into calcium plus 2 bromine ions. In this one, you're going to get 0.100 molarity. Calcium will also be 0.100 molarity, but the bromine here will be 0.200 molarity. But what do we know? Well, we actually have an issue here. The issue comes from the fact that we actually have something we call a common ion. Right there, that is called a common ion. Bromine is common in both of them. And because it's common in both of them, bromine actually has to be added up because they're the same bromine. It doesn't matter if they came from aluminum or from calcium bromide, they're still bromine regardless. So bromine actually, its ion is actually going to be 0.5 plus 0.2 is actually equal to 0.700 molarity because it's a common ion. So make sure you practice dilution questions. Make sure you know how to calculate ion calculations. As always, make sure you keep yourself safe and healthy. And I'll see you soon.